Today, I am going to discuss about image classification using CNN and TensorFlow. Contents, project description, datasets, phases, preprocessing, CNN building blocks, building network, and test sample. This project is all about building a model that classifies images to their appropriate categories using CNN and TensorFlow. Here in this particular project, the model must classify concrete images which has or does not have surface cracks on it. TensorFlow. Now, what is TensorFlow? TensorFlow is an open source software library which symbolically represents math libraries, which is also used in machine learning applications such as neural networks. This dataset contains images of various concrete surfaces with and without cracks. The image data is divided into two categories, negative and positive. Negative being images without crack, positive being images with crack. Each class has 200 images, total of 400 images, with 227 by 227 pixel and RGB channel. Reason we are using high resolution dataset is that high resolution images have high variance in terms of surface finish and illumination conditions. This project mainly has two phases, preprocessed data phase and CNN phase. Preprocessed data phase has two main functions, collecting the data, preprocessing the data. CNN phase has three main functionalities, building the network, training the network, and testing the model. Preprocessed functions. Preprocessing has mainly three steps, normalization, encoding, and randomize the data. Normalization, transforming image into NumPy array. Generally, images are in matrix form. These images are then converted into an array. Encoding, labeling the images into 0 or 1 by indexing their classes. Randomize the data. Here, we make the data as random as possible to ensure maximum randomization. CNN typically has 5 layers, convolutional layer, pooling layer, fully connected layer, loss layer, and ReLU layer. The CNN network has three layers, input layer, hidden layer, output layer. First is the input layer. This layer will accept the data and pass it to rest of the network. Hidden layers. The second type of layer is called as hidden layer. Hidden layers are either one or more in number for a neural network. Hidden layers are the ones that are actually responsible for the excellent performance and complexity of neural network. They perform multiple functions at the same time, such as data transformation, automatic feature creation, etc. The hidden layer consists of convolutional layer, max pooling layer, flattened layer, fully connected layers. The last type of layer is the output layer. The output layer holds the result or the output of the problem. Here I have taken an image of concrete that has cracks on it. By using CNN model, I classified it into image that has cracks on it, that is positive category, and the accuracy of the model is about 83%. Now let us see the code for it. To the coding part, the first part we must do is to install dependencies. The first dependency is OpenCV. So for that, the second dependency is matplotlib. Matplotlib library basically. The third one is very important. It is TensorFlow. After installing all the dependencies, we must import them. So in order to import them, the first thing is import TensorFlow as K. As you can see, all the dependencies are installed and imported to our Jupyter page. Now the next step is to load the image. For importing image into the Jupyter page, I have created 3 folders: test, train, and validation. Inside train, I have 2 folders: positive and negative. Positive folder has all the images of concrete which has cracks in it, like this. I've collected around 150 to 200 images of them, and negative has the images of concrete which has no cracks in it. In order to import these images to the Jupyter file, the code is as follows. We need to write the path of the image. So I'm taking the positive image 00081. So the path of it is train / positive 00081 dot the format of image. It is a JPG image. JPG. So the image has been loaded. In order to see it, plt dot I am show parameters image img. So as we can see, we have imported image 00081. To see the physical attributes of the input image, we need to use cv2. So cv2 dot we need the path of the image. So if we run this line, yeah, as we know, an image is a matrix representation. This is a physical attribute of that image. So for knowing the dimensions of image, the code is cv2 dot path of the image dot shape. Yeah, 227, 227, and 3. Height of the image is 227, width of the image is 227, and RGB 3. It has 3 colors in it. The next step is to generate our training and validation dataset. So in order to do it, train equal to image data generated. So we see the matrix. The values of RGB ranges from 0 to 120 approximately. I want these images to be from 0 to 1. So I will divide every single element inside the matrix by 120. Rescale equal to n by 120. Similarly, for validation set, validation equal to image data generator rescale of 120. If you run this code, no errors. Now let us convert training images to dataset. that can be fed to our neural network. So train underscore data set equal to train dot. For generating labels, we need to give flow from directory function, flow from underscore path of the training, as it is a training data set. The path would be train. The target size of the image is 227 by 227. Batch size class mode, as there are only two classes, positive and negative. So the class mode would be binary. So 267 images are found belonging to three classes. One is positive, another is negative. The third class is checkpoint. Similarly for validation dataset, copy the same code. Here it is validation. Path would be validation and train forward slash. If you run this, as you can see, there are no images. Validation folder has no images in it. Now, if you want to see the labels and the data generated, we can do it by train underscore dataset dot class indices. Neural network converts all the classes available into numerical values. Here, the negative is represented as 1, positive is represented as 2, and the checkpoint is represented as 0. To see all the classes, underscore dataset dot classes. As we can see, all the negative images are represented as 1 and all the positive are represented as 2. After we define our training and validation dataset, we have to define our model. We have two types of models, sequential and functional. Sequential API is generally used when there is one input and one output system, whereas functional API is used for multiple inputs and multiple output system. And for layers, we are using con 2D, max pooling 2D, dense, platinum. Now let us define our model. Model equal to from TensorFlow. So TF dot models dot sequential. All the layers are defined as a list. So TF dot layers dot include insert the parameters would be 16 comma 3 by 3 activation is reloop input shape equal to 7 7 and 3 and max pool include TF dot max pool parameters are together similarly 42 64 if you run this so there are no errors. Now we need to compile our model. For this model compile loss cross input So we are using RMS prop as a optimizer. So optimizer equal to RMS prop. Let's assume the learning rate to be 0.001. This accuracy. Yes. So now model is fit equal to model dot fit train data set steps per watch equal to 2 for 20 number of watches 80 validation data set. Watches are nothing but iterations. So we are taking 2 iterations for 20 steps. So the maximum accuracy is 83%. It should be fine. Now let us check how the optimizer works on testing dataset. For that, we need to define a directory path. So I have created a folder called Sai. So path would be we will read every single image from the folder and then check how the model is classifying the image. So for I OS dot is image equal to image dot plus image spaces plus comma target size 227 by 227. PLT dot show img dot show So we got an input here. Yeah. For I, now we need to convert the images into array. Capital X equal to we have to provide an additional dimension to our data or else we'll find an error. So capital X equal to np dot expand dimensions. Axis is 0. For model prediction, model dot predict, parameters will be images. As we need to classify it, it is defined value equal to if value equal to 1, print it is a crack. Value equal to variation equal else so in this we got an involved export or respective value. So we can see the model has successfully classified the image as crack image. So it has a crack. This is how we use neural networking for image classification. Thank you.